जी सर। ऑन हुआ होगा सर, हम एडमिट आपको कर 1 मिनट रुकिए, एडमिट करना है सर। गुड मॉर्निंग। हाँ हाँ बिल्कुल अटेंड करेंगे। हाँ बस समझना कि आपको अटेंड करना है बस। किसमें शो तो दिख रहा है, सबको दिख रहा है सर। आपको कैसे आपके नहीं नहीं आया, सबका आया सर। Very good morning to all of you, dear participants, faculty members, director sir, and our resource person. I, Dr. Thakur, on behalf of students, faculty members, and management of RRIMT Lucknow, I welcome you all in day 2 session of faculty development program on data management. Yesterday we done 3 different sessions on data management. Today also there are 3 different sessions in which renowned resource persons from different organizations, universities will join the session and share their valuable experiences and knowledge in the domain area. I assure you all that this FDP program will surely increase your domain knowledge and you will able to deliver or do number of projects or number of research in this area also. Yesterday we discussed some topic, advanced topics related to data security and data images, image management and different issues related to data management topics. Now we will be interact with resource person from JNU, MNNIT as well, who will deliver a very useful and fruitful discussion or knowledge sharing in this area. Today is the second day and we expect all from you to please join the session on time and adhere the time schedule given in the time chart or time schedule given in the given. Now I am very much grateful to universities and our institute to conduct this FDP program in which we are solely meant for to improve our knowledge domain and look inside the topic related to data management. Today the first session will be joined by Professor D.K. Lobial sir, who is Dean and Professor in Jawaharlal Nehru University, New Delhi. Today's session of data of Professor D.K. Lobial sir is on computer network and data management, how to manage data on over the network, computer network. Our directors are also joined this session. I request director sir to enlighten some brief about this, as Lobial sir also joined this session. I welcome. Good morning, Lobial sir.
Good morning.
Good morning, sir. Good morning.
Namaskar. Good morning.
Welcome you, sir. This is day 2 session of this FDP program.
सर नमस्कार. त्रिपाठी सर को नमस्कार.
नमस्कार. नमस्ते नमस्ते. कैसे हैं?
सर ठीक हूँ.
चलिए बड़ा अच्छा लगा. बहुत दिनों बाद हम लोग ऑनलाइन.
हमें सर आपने बुलाया. अच्छा मुझे तो आना ही था.
जी 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 जी.
Director sir, if you want to say something about the Lobial sir, as he is very much. Please, sir.
Today we are going to. Today is the second day of data management session. और इसकी शुरुआत करते हुए मुझे खुशी हो रही है कि डीके लोबियाल साहब आज का पहला सेशन कवर करेंगे. डीके लोबियाल जी को 1984 से जानता हूँ. 15 साल उधर और 20 साल इधर, 35 साल. ये भी बहुत युवा थे. ये तो इनके ज्यादा. और जैसे माँ बाप पहली संतान को बहुत ही ज्यादा मानते हैं, बहुत ही लाड़ प्यार से लालन पोषण करते हैं, ऐसे ही डीके लोबियाल भी इस शिक्षा जगत के पहले संतान है और उन्हें सत्य के पथ को धर के जीवन की ऊंचाइयों की सीढ़ियां चढ़ना शुरू किया. और सबसे अच्छी बात है कि किसी भी पद पे रहे, इनके अंदर कभी भी घमंड नहीं आया. ये अपने आप में एक बहुत ही अद्भुत चीज और इनका मेरे प्रति आदर और स्नेह वैसे ही रहा जैसे 1988 के पहले था. मैं इनको जब भी देखता हूँ मुझे वही डीके लोबियाल जी याद आते हैं. हम लोग 35 साल पहले, 88-12 कह सकते हैं, 32 साल पहले बताया. मैंने जैसे ही फोन किया कि हम एफटीपी कराने जा रहे हैं, उसने कहा मुझे सब जानना ही आना ही है, जिस दिन मन करे जब मन करे तब लगा दी. और आज कल जब मैंने इनको फोन किया तो कहा सर मुझे बिल्कुल याद है, मैं जरूर टाइम से ज्वाइन कर लूंगा. और आज भी बिल्कुल टाइम से ज्वाइन कर लिए. इनके और आपके बीच में मैं और ज्यादा नहीं आना चाहता और मैं भावेश से आज की कार्रवाई मेरा आशीर्वाद है डीके लोबियाल जी को. स्वागत भी करता हूँ और यह सबसे कहता हूँ कि आज के विद्यार्थियों को डीके लोबियाल जी से सीखना चाहिए कि कैसे जीवन में व्यवहार करते हैं. धन्यवाद.
Welcome you, sir, again. Welcome you, sir, again. This session. Now over to Dipti ma'am. Please introduce Lobial sir.
Thank you, sir. Thank you so much. A very warm good morning to all of you. I, Dipti Ranjan, on the behalf of RRIMG, welcome you all for the fourth session on second day of AKTU-sponsored FDP on data management. Today we are blessed with the session expert, Professor D.K. Lobial sir, with us. He is presently Professor and Dean in JNU, Delhi. Sir expertise areas are mobile network, natural language processing, and video on demand. Sir having more than 23 years of experience. Sir, I'm again welcoming you. Now over to you, sir.
Thank you very much, Dr. Deepti and Dr. Bhavesh, and special thank you to my Guruji, sir, Professor Tripathi sir, and I thank him for so nice words. And we still feel we are his students. Whenever he orders, let me call it order because I respect him so much, and we never can say no to him. And wherever he wants to utilize our services or whatever he says to us, we take it as granted because we cannot deny his words. That's the first thing I like to tell. And because see, when you the scene today and the 84, 85, it is very different. When we came from very small places, from Uttarakhand or like other places in the country, and And when you come to a big place like Lucknow that time, it is very much important than how people treat you. And I think Professor Tripathi sir is one of those who has been very friendly and treated students as if they are his family. That's the most important part of him, and therefore we still respect him from our heart and so much. And we cannot say no to him anytime. That's the important part of it. And he is also the same what he was in 1984, 88, 80, when we left IIT. And we found him still, he is the same person and he treats us in the same way. That's the greatness of him. And therefore, we owe all respect to him. And because of him, I'm here. And we say that we have to deliver a lecture on computer network or on this FDP, which is basically on data management. Though I don't work on data management, then he said, okay, computer network में तुम काम करते हो और data management से related है, इसको कुछ बोल दो. मैंने कहा सर ठीक है जैसे आप आदेश करते हैं. And then I thought what to talk on computer network and data management. And then I thought let me link my topic with computer network. Especially I'll go on 5G and data management because the 5G will create a lot of data. That's what I thought I should talk on. That's what I'll go, but still. So with these words, I'll begin. I'm very thankful to all people who taught me, or including Paddy, all educational institutions where from I have got my education. This is a great opportunity to come from small places and rural India to come to Delhi. Even people go abroad, fine. But it's a big thing for people like us who come from small places and get education and get opportunity to get education in the institutions like IIT or JNU, wherever we go. That's what we are fortunate enough that. After having said this, without wasting much of time, let me share my Dr. Bhavesh.
Yes, sir.
So after 1 hour, there will be a break.
As
Hello?
convenience, sir, please.
Okay.
Total.
Because it will be also very tiring for the participants as well.
No issue, sir. As per your call, sir.
Okay. So let me share my screen. मेरी आवाज तो ठीक से आ रही है?
बिल्कुल आ रही है सर, बिल्कुल साफ आ रही है.
ठीक है. मैंने कहा नेटवर्क का इशू नहीं है. Now my slides are visible?
Yes, sir.
Okay. Then I'll begin with my topic. Though the time,
If you don't mind,
the title is computer
full
network and
screen,
data
sir.
management.
Yes, sir.
कभी भी अगर नेटवर्क गड़बड़ाएगा तो आप मुझे बता दीजिए बस. हाँ.
ठीक है सर, फुल स्क्रीन if you don't mind, sir.
मैंने तो फुली किया आया नहीं.
ठीक सर, ठीक. ओके.
आया नहीं फुल.
आ गया सर, आ गया.
So today's topic is computer network and data management, and though as I said in the beginning, I don't work much on data network, but nevertheless, so therefore my lecture most likely will be on the network part. And since it is a lecture on, I'll not be very technical on the lecture part. So not going into the technical depth, but it will be more of a what you call spreading of a knowledge about what 5G and what are the issues of data management will come with the 5G. That is what I'll focus on. This lecture, anyway, I'll call it, will be delivered in 3 parts. The moment I say 3 parts, it's not that one part is delivered, I'll stop and go to the next part. The sense here is, I'll talk of 3 different things in a way: data management, 5G network, and basically computer network. I'm not going to teach you the layers. That is what not I mean the computer network. So 3 parts, but it will be in a flow. That is what I have tried my best to do that. That's what it is. But largely this lecture will be on 5G network. That's what the idea of the lecture is. Then a few slides, not much. I will be talking about what are the issues of data management in 5G and how data management in 5G is significant. That is what in few slides, 5-7 slides I'll talk on, not much on data management. So by and large, my lecture will not be covering much of data management and will be covering 5G network. And I don't know whether it will be justifiable or not, but that's what I leave it to you, whether it will be justifiable. And let me begin with simple. I understand every one of you knows what computer network is. Therefore, I'm not going to talk on it. But I see a network, any kind of network we take, whether we take a fixed wired network or mobile wireless network or a wired network, any model of network you take, it consists of basically 3 planes. One is a data plane where the user's data which travels across, or the traffic of the application which travels across, it needs all the processing techniques for this data plane. We'll talk of processing of the user traffic which, or the application traffic which travels across the network. That's what the data plane. That means we need the techniques and algorithms to process this. So therefore, the huge amount of data is produced there, which needs to be dealt in a very efficient way. Why I said dealt very, I'll talk a little later. And then there is a control plane where how to deliver the data. That is signaling of traffic, the process of signaling of traffic. That means whether you make a frame, what kind of headers you should have in the frame, or what kind of tellers. All those control issues comes, and what kind of signaling bandwidth to use, same frequency is used for this or other, if you look at the cellular network. So that means how the techniques and algorithms and protocols used for helping the transfer of the user data. That is what the controlling of the data. That is what is covered by the control plane. Then comes the management plane, where how an application will interact with the network, or how that's what the important part. Who is authorized to access the network? Who has access to the various component of the network, how to manage your routers, if you put that way, any device. If you take a router as a device, it consists of almost 3 planes. It has to deliver the user's data, have the controlling over the data. It must also provide certain kind of access to the owner of the network. That's what it is, where you manage that. If you take a mobile network, when 2 network joins together to make a bigger network, then how to who will join at what time, you take a ad hoc network. So that's what the management plane talks about. And if you look at all 3 planes, why I talk about, all talks of dealing with different kind of data. And if you look at management data, if the cellular network to take into account, the billing process also is part of the management, where a lot of data has to be generated and managed and organized. Now the question what I am trying to say is, so the data management basically will deal with the traffic data and the management data by and large. Right? That's where the network and the data management may be related with each other. And so therefore, what I'm trying to say is, if you look at your mobile network, especially wireless sensor network, coming off the wireless sensor network, it's a huge, it is a source of huge data generation. In a sensor network, you cannot have a small, in a sense, not a very few number of nodes. The magnitude of the number of nodes has to be large, because even a single event to be sensed will require more than 1 sensor, because as you see, if a classroom is being covered, 1 camera as a sensor is not sufficient to cover it, because it will take only 1 directional images or the video. So you need multiple cameras to cover the whole class interaction of the class, live class going on. That is one event or a phenomena to be measured needs a number of sensors. And if you are measuring a big area, then you need a lot of sensors to take a measurement of that or take the to measure the phenomena across that area. So it's a huge source of data generation, and therefore the management of that data becomes very, very important. It's not from the perspective of the data coming to a sync node, that is a central location, then you manage it, because central location we have a huge storage, and then that huge storage maybe a central location running on a AC power, not on the battery power, because it is placed at one place. There is no mobility. And it may have a huge computing power, no doubt about it. But the amount of data which is being generated per second or per minute, maybe that huge, even the processing of that data requires a lot of things. That's what I'm trying to say. And then whether the data is significant or not, well, you need a very lot of data analytics. But when I'm taking or talking of wireless sensor networks, when the sensor nodes deliver data, it's not only you, as I said, deliver the data to the central location, which I call a sink. But the question is, when the data is being delivered, you have a limited bandwidth. When you have a limited bandwidth, then you need to filter out the data. That means even at the node, you need techniques which try to manage the data. In a sense, the filtration of a data is one of the way of managing data. You take the key data which is significant, important for your application, and discard the rest, so that you deliver a small amount of data on a limited bandwidth channel. That's what's important. And not only that, that you only filter out data what is significant to you, then you need certain kind of aggregation techniques of data, and that's important. So what I'm trying to say is the algorithms, the techniques of data management may be very useful in that case, and these algorithms and protocols has to be very lightweight, especially in sensor network I'm talking, because the sensor has a very limited capacity in terms of memory, processing power, whether you take a battery life. So the processing and storage capacity being very limited, the huge processors cannot work on data. So you need a very lightweight processor which can quickly process the data. That is what another challenge of data management, it comes with the huge wireless sensor network. Now, how this will become more challenging when 5G comes, that is what I'm trying to say. So this may involve also data analytical techniques to be used for that. And not only that, if you look at the cellular network, which used for telephone initially for making phone calls, 1G, 2G, 3G, I'll talk a little later, they all came for using for communication as a call, but gradually they are integrated with the data network as well. That's not only integrated, they are made to accommodate the transmission of data as well in addition to the voice calls. So therefore, it also needs a lot of techniques to use. There is a limited mobility only in the last year. The cellular phones are mobile, infrastructure is stationary, but still you need a lot of data techniques, that is what I'm saying, and with its integration with the other networks, probably it needs better data management. When I say it's integration with the rest of the, just 1 minute. So what you need is, when I say integration, if you look at, the 4G, now it is one of the expected thing to come. That all network, like whether you take a wireless personal area network like Bluetooth kind of thing, or you take a wireless LAN like Wi-Fi network around some place, or you look at a WiMAX, which is a wireless metropolitan area network, or you take a very what you call GSM or cellular based network, or which we call WIMA, wireless what you call, yes, wide area network for wireless wide area network. Even you take a satellite network, taking your all what you call geosynchronous based networks. If you integrate them, that is what I'm saying. If you go to an area where your cellular network does not have a coverage, because you find a message, you're out of coverage area, that means the mobile operator does not provide service in that area. So you are deprived of a service and you cannot talk. Therefore, the question is, if this network of cellular is integrated with the satellite network, so it will switch over to the satellite network rather than making a phone call from only GSM system or cellular system. It will hand over to the satellite network on those places where there is no service available by the cellular network. So still your service will continue. That is what we call a vertical handoff at times. When it is being handed over from one network to other network, we call a vertical handoff. Now that is what I am trying to say here is, the plan or the even 4G onwards, that was one of the research area where people have been working on heterogeneity of the network, where various kinds of network are combined together. I have made this diagram. This diagram is based on the satellite network at a large coverage, based on the coverage, then worldwide wireless, worldwide network has a lower coverage, then MAN has lower, then LAN has lower, then PAN has lower coverage. So that's what, but you are going from one network to another network. If you integrate all these networks, the challenge of data management becomes more difficult, because some of the network has huge bandwidth, which may be able to transfer huge amount of data. Some networks, if you look at, has a very limited bandwidth. Higher the network, the limited is going to be the bandwidth, as well as the error rate is going to be high. If you go to the lower side, the bandwidth, the wireless, you take LAN has a huge bandwidth, and the error probability is very low because the distance traveled is very small. So it is going to put more challenges, but at the same time, it will try to accommodate more data, and then how to deal with that and with the different applications. That's what the whole idea is. That's what I was saying. Then all these kinds of networks are combined together. It may be Wi-Fi or Ethernet-based network, or it may be a GSM. Like say one node moves from there to there, and then it moves to Wi-Fi, Ethernet to Wi-Fi, then Wi-Fi to, it may go to the cellular network. That's what the whole idea of it is. So what I'm trying to say is, the mobile or the cellular network does not remain a smaller network designed for a small purpose. Rather, they have become a integrated network where one will deal with the traffic coming from the other network. Therefore, the traffic data management becomes more difficult and more challenging. That is what the whole idea of talking that part of the lecture. How this becomes a bigger challenge when it comes to 5G network. That's what I'll go in. But before I go on data management in 5G, let me start with the 5G. What is 5G network? That's what, which is supposed to come, was supposed to come in 2020, but it has not been delivered. Hoping to come in 2022 because there is a pandemic and all other issues came. So let me go on the second part of the lecture, which I call 5G network. And I'll cover in a small part that I'll talk of, give a small introduction of 5G network, where how to switch over from one generation to other generation takes. I'm not going on what one generation do. That way I'm not going to make this lecture because many of you know about the generations, you teach that course as well. And then what are the basic important themes of 5G when it was started to be developed? That means there are limits of demand, how much demand you can do from the technology, how much demand you can have from a network. There are limitations of that demand. There are limitations of the technology as well. Technology cannot fulfill all the demands put by the human users or the network users all across the world. And there is a limited vision of the 5G. There may be certain themes, then in addition to that, there is a region whether we'll achieve all or not. Then there are some applications, and then I'll talk of summary of 5G. Then third part, I'll go on data management. I said in the beginning. So this is what the growth is. See, every 10 years, these networks started coming. 1G came in 82. There may be some say 81, 82, but let's take 82. Then 2G came in 92. Then 2002, 3G. 4G came in 2012, and 2022, the 5G is expected. Though there have been trials in 2016 Olympic, if I'm correct, in Seoul. This is what every 10 years, if you look at, there is a generational change in the mobile communication. So if you look at from moving to one network to another network, I'll take this because this will be able, this will help us to understand where we are at 5G. That is what the basic idea I took from, I take to make the lecture maybe more relevant. So let me go through simply that that everybody knows that 1G was an analog-based system, and the handsets used to be bulky. That's one part. But what is the problem with the 1G and then we move to 2G? That is what my focus is. One was the issue of the security because there was easy to phone cloning and identity of the stealing of identity of the users. There are not much security issues taken at this time, and apps dropping is always easier for wireless. But as we grow, we keep on improving the security services. That was the biggest problem with the 1G. Second was the fragmentation. That means a different country was using different technology. We do not have a technology kind of a GSM system at that point of time. US use a different kind of technology. Japan use different, and the rest of the Europe and Asian countries use a different kind of techniques. Still, we do that, but the fragmentation has been reduced. But there is also integration between these fragments now. But initially, these were the big challenges. And the cost of delivery was very high. In a sense, 1G network was very costly. Only the wealthy people used to afford it. And the quality of and the capacity of the analog transmission, was low and poor. And therefore, the 2G was evolved to overcome the issues I laid down here for 1G. So fundamental issue was that whole system was analog based. Therefore, we have to move to the digital system. So 2G resolved all these issues to a fair degree it has been able to resolve. But still a lot of issues remain. Therefore, we move to another generation. That is how it happened. But if you look at 2G, 2G was fully digital, communication. It added certain security features, as I said, apps dropping, and was very easier in the 1G. And not only dropping, the identity stealing and phone cloning was easy. Even phone cloning also being done today that you can talk about. The voice quality was very poor in 1G because of the analog system, because of the noise. So that is what 2G improved. An important point was GSM, Global System for Mobile Communication, was introduced by the European system. And also CDMA was introduced at that point of time by the Americans. And two systems came, GSM and Code Division Multiplexer, CDMA, in 2G. Though CDMA could not become much, whereas GSM took it off. So the roaming was possible through, which was not possible with the 1G and 1G, because I said there is a fragmented network, no integration. So roaming was not possible in 1G, and because of the standard technology like GSM or CDMA, the roaming became important or possible in Europe because every country was using GSM-based network. That was another big advantage with the 2G. Also, the data services like SMS-based services started with the 2G with using GPRS, that you know. And the handsets was also improved. The size was reduced. It was not bulky that you can, so you can put the 2G phones in pocket as well. So 2G was one of the highly successful technology that you have to keep in mind. 3G was not that successful at 2G. So then comes the problems with the 2G, which lead us to move to 3G network. So one of the problem was the data rate was very low. So therefore we cannot run the video or kind of things on this. Could not deliver attractive internet services as we use today. And not only that, the videos cannot be transferred on 2G. That was the problem. Still, a lot of students from remote where 2G is running, they said we have a problem of internet connectivity for online education because of the corona pandemic. That is what the complaints are coming right now. So therefore, the multimedia service it cannot support also pictures and adding pictures and videos with the text. And then the spectrum efficiency was one of the issue that means how much given the spectrum can be utilized in the best way. That was also a difficulty to with the 2G, that it was not giving high throughput. And the call range was very small. That means you cannot make call to a very small. This needed many base stations. So therefore you need multiple base stations. The cost of implementing 2G was high. So that led to the evolution of 3G, which slowly tried to address the issues raised in 2G. But 3G did not resolve all those issues. Look at what 3G did and what were the problems with the 3G. 3G basically aimed at using CDMA for spectral efficiency. That means how many users I can support per megahertz or gigahertz, whatever you need to take of the spectrum. If I take kilohertz as a unit of a of a channel, then say per channel how many users you are able to deal with. So CDMA was made with that aim that it should give you a higher spectral efficiency. That means per channel you will be, or per megahertz or gigahertz user will be more than what we have been doing. That was the idea. So it was made to provide a high data rate for video services. That is how we started with the 3G. You can have a video services. We started watching video services. And it used both packet switching and circuit switching, whereas up to 2G, the packet switching was not much used. Packet switching came with the GPRS. Otherwise, most of the 2G network was with the circuit switching. One of the important development took place, which was the emergence of iPhone, because watching video on this 3G with the phones which were coming before iPhone was difficult, because the font size and the quality of graphics was not good. So iPhone also transformed this browsing of internet, watching video on the large screen or better quality screens of the mobile. So it's not only that your whole network technology brings transformation, but along with that, the other equipment which you use like phones, they also bring certain kind of transformation or revolution in the this communication industry. But iPhones are very costly, though it caused rapid growth in the data demand also, because we can watch high quality videos or little better quality videos. So large videos can also be watched. Therefore, the bandwidth should be high, the speed of data should be high, the latency should be reduced. All these issues started creeping up. That's what happened with the emergence of iPhone in between. But 3G did not become very highly successful technology. That's also one of the important points. It may have, it is many regions, but somehow it will not pick up that way. If you look from this angle, So what are the problems with the 3G? It was a slow evolution. That the CDMA, the effective implementation of CDMA was difficult. That is what, if you bought Reliance phones one time, which was CDMA based, but now everything is gone. So this did not pick up that way much. Then the implementational issues came up, and then in between came high-speed packet access that improved data rate. And that was what you call improved 3G, 3.5G. Some people call it 3.5G. Even if you increase the speed or the data rate of the network, but latency became one of the big issues. That was still unacceptable because you try to download a video, it used to take a lot of time. When you are using, you are with the interactive session of internet, the latency is a very, very important issue. So high data rate with 3G did not improve the latency of the network. And thus, yes, small screen size of phones, if you leave aside iPhones, also was a difficulty in browsing the internet. And therefore, the internet adoption with the 3G was slow because of the limited font size. But if you make a big font size, that also is a problem. Also, it was also the adoption of what you call the delivery of the video content on the phones from kind of a desktop or laptop kind of, which are designed for desktop kind of applications. And then whole change took place slowly, where we have to adopt to the kind of screen size or the limited memory or buffering of the mobile phones. That is one of the reasons that it could not pick up that way faster, and it started taking slow. It was also a difficulty to mix both circuit switching and packet switching, and that was still, if you do your voice over IP, then you have a lot of cracks in the voice. The region is that is being delivered via the packet switching. But whenever a call comes, your packet again becomes slow on the 3G. Because the moment a call comes, the phone or the network switches to the circuit switching from the packet switching. And the packet switching has a low priority than the voice, and the data has a low priority than the voice. Therefore, voice has to be dealt with the packet circuit switching. But if the voice is dealt with the packet switching, you have a lot of cracks in the voice. We are not able to make out what the person from the other side is talking about. That is what happens with the voice over IP. Because voice over IP uses packet switching for the voice. So the mixing of both was a difficulty, and management of this switching from one packet switch to circuit switch to packet switch also make the management difficult. This reduces the efficiency of the network and made it very difficult to manage the network. These were the issues with the 3G. Despite your high-speed packet access, could be some of the demands what posed with the 3G, but 3G has not been able to meet all the demands, users' demand, like it must be able to deliver high-quality videos with low latency. Not only that, I should have connectivity all across. That was not fulfilled by the 3G. Therefore, that raised what you call demand for the 4G, and which try to address these issues. We also started 3G PPP projects where we thought of what you call later on they call long-term evolution, which you call 4G. So 4G started with the improvement of the 3G, but we landed with the 4G. Landed up with the 4G. That is what was the issue. And what happened in the 4G now? If you look at that, it started using orthogonal frequency division multiplexing. That is a huge topic which we will talk nowadays. To improve the efficiency, spectrum efficiency, as well as the network efficiency. Then another important issue with the 4G was it removed circuit switching fully. Now all will be packet switching, IP based. No circuit switching in 4G. That was the idea. Also the voice, that the VoIP which used to be with 3G, now we call it a VoLT, voice over long-term evolution. where all voice will be carried by the packet receipt, and you can see the voice quality is good in 4G. Network improved even if it is doing through the packet switch, which was very, very bad in case of 3G. The voice used to break and there were cracks in the voice. And then a wider frequency channels and improve the latency. That means we used the channel capacity was frequency channels were with higher bands, and therefore the latency was improved. That low latency came because it can send more data with the smaller time and less time. 4G also was a very stable and optimized data network, and that is what sometimes is all even generations were stable network. 2G and 4G are very stable network, whereas 1G and 3G has not been that stable. So people believe that 5G also, those who are little bit of conservative, they say all generations are not very stable. So 5G people have doubt that it will be a stable generation. 6G will be a very stable generation when it comes with all your network with the AI applications will lead to 6G. But 4G is a stable and data optimized network. The spectrum efficiency, as I said, the number of users you can deal per megahertz or gigahertz, kilohertz, whatever you take, is increased 2.5 times from 3G in 4G. 4G has 2.5 times more spectral efficiency than 3G. And that way the 4G became a highly successful technology. When I talk this, we are not using it much, but everything starts with the Western world. It is a very highly stable technology. But still it has its own limitations. That's what the challenge is. The limitations of 4G, if you look at it does not provide largely sufficient data rate. We need data rate much more than what 4G provides. That I'll talk. And it still uses a frequency below 6 gigahertz. Therefore, we have a limited number of channels available to us because all bandwidth is below 6G is used for different kind of applications, and that's also an issue. So we have always a limited bandwidth available for 4G as well. So there's a limitation of data rate also, but though it improved from the 3G, but still the demands are very high, that's what I'm trying to say. So therefore the 4G probably cannot deal with massive number of devices. When we talk of IoT today, and we feel that a huge number of devices will be connected to the home with the network. So even in a local place like your home, you need a huge bandwidth to deal with maybe 10, 20, maybe 100 devices. If you have a lot of sensors put at your home for different purpose and everything is connected with the network, and it needs a huge bandwidth for this connectivity. So frequency below 6G may be an issue that will limit the data rate and the bandwidth. And the latency, though it was reduced to 30 to 50 milliseconds, but still it's not, it needs more reduction also. That I'll talk what does it mean. Because high quality HDD quality video still needs low latency to watch them through interactive sessions. That's a big issue. So it improved latency to a quite good extent, but still there's a demand for a reduction of the latency or the delay, and that I mean to say in delay. Because the kind of the application which we are going to in the future is the virtual reality or augmented reality, interactive games, then where maybe a huge number of players are playing games interactively together on the internet, which can use huge bandwidth, and needs a faster response. Therefore, you need a very low latency. That is still a challenge, which 4G will not be able to fulfill. So what I'm trying to say is, one is the limitation because 4G uses the frequency band, below 6 gigahertz, where is a limitation of a frequency, what we call bandwidth. And also the latency is an issue for augmented virtual reality or virtual reality, as well as interactive game services. So that is where the 5G comes in. and we'll try to address these issues. So let me introduce. The 5G has certain themes. Themes means what it is going to do, the focus idea of 5G. Now, each generation, if you look from 1G to 2G to 3G to 4G, had a single theme that it needs a faster data delivery. And that it feels that the faster delivery means the latency will automatically be taken into account. अगर data fast deliver हो जाएगा तो delay कम हो जाएगा. That is what the whole idea of all generations. Therefore, you see that 1G analog to when you move to digital, the data rate became higher. When 3G, it has used, it started also with the improved data rate to transfer videos and pictures as well. And we started watching videos with that. And 4G, we said we'll be able to have a better data rate and even reduce the latency. That is what. But the theme almost is only on improving the data rate, faster data rate. But 5G is the network where we have multiple themes. Not only that we have a theme where we want to improve the data rate, but it has three themes. These multiple means there are three themes. One is that enhanced mobile broadband. That is what is said, the faster broadband connectivity than 4G. Right? Will provide higher bandwidth, therefore the data rate will increase. Then the 4G, that means we'll go beyond 6 gigahertz. 6 gigahertz band will go beyond that. That is what the enhanced mobile broadband means, and I'll explain in detail as well. The moment as a machine-machine connectivity, I'm talking of IoT. Multiple devices will be connected with the network. At the same time, it will be able to deal with huge number of devices simultaneously. So therefore, the Internet of Things will be a success with the 5G. So that means the Internet of Things also pushed for this theme in 5G. Then we talk about ultra low latency. My end-to-end delay should be very low. Maybe 1 millisecond or 5 milliseconds can we reach to that level. So the radio solutions for application of like virtual reality, I'm repeating it again, will need a very low latency, maybe a few milliseconds. I'll talk a little later how much a video needs, that we'll talk about. And so three themes: enhanced EMB, enhanced mobile broadband, MMC or IoT, I'll call massive machine connectivity, and then ULL, that is ultra low latency. That are three themes of 5G. Therefore, the 5G technology makes, how do we achieve that? That's what I'm trying to say. 5G technology make use of beamforming, that will have multiple input and output antenna. So one antenna will cover only in a direction, the other will cover other direction. So that means I am forming a beam in a direction, and my signal will travel to a longer distance, and it may give you huge bandwidth. The sharing is not a large number of users sharing that beam will be reduced, or other users in that direction will share the other beam. So that way we may be achieving a high data rate. MIMO came in 4G as well, so it's not new to 5G, but 5G scales the MIMO. That is, 4G was using 8 antenna, and 5G proposes to use 128 antenna in 5G. So 8 antenna to 128 antennas is a huge change in the technology. So therefore, if you have 128 antennas working in different directions, the number of users you are going to use, or the spectrum, your efficiency is going to increase is very high. So that is how you can handle a large number of users or connectivity. That's one idea. So that's what we call a massive MIMO. So in 5G, we also call it massive machine connectivity, also called massive MIMO technology. In addition to this, 5G also suggested some change in the core network where my routers and all switches are put, is there some change or not? That's what the changes in core network. My routing framework or switching should have certain change, enhanced flexibility. There must be. So it said we use virtualization in case of our change to enhance the network flexibility. That in addition to only the hardware, we have software solutions or cloud-based solutions for the switching other issues, and that will probably improve this provide flexibility. And not only that, the 5G spectrum, what it started using is a low bandwidth of 700 megahertz, which will provide the huge coverage. That means if you have to cover the large distance, you need lower frequency. So the 700 megahertz band was suggested that it will give a wider coverage. But sometimes the coverage, you need more users to be handled and sort of coverage to be given. Okay. If you need that, then you need 28 gigahertz maybe, which is what you call to be used for a low latency. Because if you have a huge bandwidth using 28 gigahertz, the latency will be reduced, and it can be it will transfer data fast, but it will be working in a small distance. The coverage will be lower in distance. So to be used for fixed wireless access, that means at your home. Now, if you use your Wi-Fi and there are 6, 8 homes around, everybody using your Wi-Fi, then you have a problem. So if a kind of service comes in your local area and where huge bandwidth of 28 gigahertz is used, probably you can have more devices to be connected. That is what we call home broadband wireless. And initially provides uses a 3.5 gigahertz band called key band of 5G for EMB, enhanced mobile broadband, where you will try to do the middle kind of where you are from your mobile to a cell phone. Probably we can use 3.5 gigahertz. So this is an intermediate band where we need a moderate coverage as well as a moderate data rate. So we'll use the three band frequency bands are suggested by 5G also. I think I'll stop here and then 5 will begin. Hello?
Yes, sir.
We'll take a break here, right?
Okay, if you want, sir, please, sir, please. After
Yeah.
5 minutes, we will start. We will.
5 minutes? Yeah.
Two.
Yeah. So I'll not start quickly.
How much?
पानी पी लेता हूँ.
Yes, please, sir, please.
5 minutes?
नहीं ठीक है.
I don't need much time.
Fine.
Okay.
Yes, sir.
Okay.
No issue, sir.
Yes, sir.
Dear participants, this is one of the very fruitful session, and this is a 5 minute break only. Please be easy, and again we will join this session. दिल्ली बॉम्बे तक आवाज आ रही है, कब ले दिल्ली बॉम्बे तक आवाज आ रही है.
Hello.
Yes, sir. Welcome back, sir.
शुरू करें?
Yes, sir. Please, please.
Thank you.
We last at limits of demand.
Yeah. So what we covered is the different kind of spectrum or band required by 5G. And that is how it will be able to provide you the massive service or the higher data rate. But there are, as I said, there are limits on the demand, but how do you measure the demand? Always in mobile communication or mobile communication system, the demand is measured in terms of how much volume of data is being transmitted or used monthly. That's what the capacity is. And there is always a limit on that. And that limit also keeps on increasing depending on the services coming all across. But at the same time, technology has its own limits. But the motivation for the new generation is the speed, not the volume that we have to keep it. That how quickly we can deliver data rather than how much volume of data we deliver. That has not been a demand for new generations. So therefore, in general, the volume of data remains unchanged regardless of the rate. See, if you need to watch a movie online, if you need this much data to be transferred, and volume of data has to be transmit within a minute, that will remain constant. But how fast we are able to deliver it? If you are not able to deliver it faster, even if you are doing buffering, we need to deliver it faster so that you can meet that. Always you can see there is a correlation between volume and rate that I'm not going to talk much on. But you just perform certain activities and that needs high data rate. But if you reach up to a certain data rate, it triggers a certain change in demand. Like say, for example, when you have been using 3G, 2G, we have never talked about transmitting a video, interactive video on the internet. And when we reach that data rate where you have been able to do certain kind of services, then all of a sudden the video services came that triggered the demand for the higher data rate. That is how always happens in case of a mobile generations. So the MNO, mobile network operators, they see the demand for the data network, therefore they change from one network to another network. So therefore, it can be expected that once speed crosses a threshold rate, the data demand would fade out. That is what is expected, that while we are meeting the various demands, like for HDD video, once you meet that demand, then it is also expected that the demand for higher data rate may fade away. But the question what I'm trying to raise this is, will there be a new generation which will again require a higher data rate or not? But sometimes probably you have HDD high quality video, 2000 cross 2000 videos with high color quality if coming up. How long you will go? Probably if that threshold is crossed, the data rate, high data rate demand may fade away. That is what is expected, but we never know. So the important goal of having a higher data rate is to improve the user's experience. What we experience while watching a video, that must be improved. And also, we must utilize this meeting while demand, then provide more efficiency in terms of the throughput. And also the spectrum order, in order to allow network to carry increased traffic. The throughput should be measured in terms of the units of radio spectrum per gigahertz, how much data we are able to carry. And that is what, and to what extent 5G meets those demands. So what I said is, my demand is that higher data rate to improve the user experience, and that is what I need, higher data rate. the user feel that he's able to watch a movie continuously without any break, or able to play a game, or used to run a virtual reality application without having a break in a very smooth fashion. So his experience will be good. And per gigahertz, how much data I am able to deliver. That's what, whether 5G will meet those demands or not. That's what important point is. That has to be seen while 5G comes in. It's a question mark. Lot of operators of 5G still are not coming ahead. They feel that they will not get the revenue in return if they deploy 5G. The reason being the deployment of 5G will require a lot of changes in the technology. But all, see, earlier generations, if you are using a 2
हेलो, हाँ सतीश जी, भावेश ठाकुर बोल रहा हूँ। हेलो, हाँ सतीश जी, भावेश ठाकुर बोल रहा हूँ। अरे यही ऑफिस से चले, लाइट आ गई, लाइट दिन सर ने बताया।
So previous mobile generation did not have a vision such as.
चलिए अब लाइट आ गई, थोड़ा ध्यान
So they
रखिए।
aimed at resolving the generation is the generation 2 address was evolved to address the issues of generation 1, 3 for generation 2, issues of generation 4, and so on and so forth, and provide faster connectivity. And the theme was to give the higher data rate. Whereas 5G has a collection of regions, if you look at that. So the expected general expectation what 5G will deliver once it is deployed is improved user experience, potential for new services. See, keep one thing in mind. It's not that only we feel while a generation comes that will improve whatever the problem with the previous generation is. It also, a new generation always feels that with the deployment of new generation, new services should also emerge. So in addition to the virtual reality and interactive games, we don't know which other kind of applications with the 5G will emerge out. So then probably that whether 5G will be able to deliver or not, or we may move to other kind of generations. That's what the potential for new services are also expected from 5G. We'll talk. So to deliver the general expectation, then what does 5G should follow? That the connectivity for multiple devices and services with 100% geographic coverage. Now that means 5G, with 5G we feel that it must provide that we should have 100% coverage. We should not find a kind of messages where say you are out of coverage area. So connecting a large number of devices as well as providing coverage in all, everywhere, anywhere, wherever you go. That is the whole idea. And then it should be able to combine different kind of signals. That is the question. 7 megahertz, 3.5 gigahertz, and 28 ultra high frequency millimeter waves. Can it combine all together or not? That's what is expected. If this happens, criteria is met, only then 5G will be able to deliver. And ultimately, we are also expecting that it will provide you a very low latency, maybe up to 1 milliseconds or 5 milliseconds. Then we'll be able to provide the kind of services we are talking about. Also, it should be able to bring together the multi-delivery platforms together. That I gave a diagram. We should be able to integrate Bluetooth, Wi-Fi, satellite, and your cellular phone, everything together under one umbrella. Can they have a connectivity and integration together? That probably happened with the 5G. Then technology to support a wide mix of different services and different kind of solutions, which will talk what kind of services it can provide, using a very ultra fast bandwidth. So ultimately, this is a quote I have taken, with the vision appearing from multiple sources, mobile network operators came together under the project called Next Generation Mobile Network. That is how the whole 5G started emerging. And they gave a vision and they summarized it. I'll read from here. It said, end-to-end ecosystem to enable a fully mobile and connected society which empower value creation towards customers and partners through existing and emerging use cases, and delivered with consistent experience and enabled by the sustainable business models. So that means what it is trying to say is, when I say emerging use cases, which new potential services must come, like whether you can have a connectivity on the train while you are moving on the train. Currently, you see if you go to a tunnel or very locations which are, then you find a problem of the network, that your connection is lost. So we'll be able to provide a continuous service wherever we are, even on flying on the train or flying on the aeroplane. I should be getting a continuous connectivity without any break or disconnections. That is one. So this may be one use case. The healthcare system, other use case. So I should be able to provide consistent. The user must have a consistent experience. You should not feel that, oh, there is a packet by service, and the services provided by the 5G should be must provide a sustainable business model. That is what the network operators talked about at that time. So leaving that aside, so the important point what I am talking here is the manufacturers who are going to manufacture different equipments for 5G, whether it's the routers, switches, or even mobile equipments in future, they have suggested performance expectation from 5G. What it is expected from the 5G, it will be 1,000 times increase in mobile data volume. The volume of data which is being generated today by the mobile, it will increasing 1,000 times more. That is, as I said, then data management definitely will become difficult. That's the issue. Huge amount of data, even the searching techniques, whatever you call, will be a difficulty. Then it also assumes that 10 to 100 times increase in connected device. As a massive machine connectivity, when I take, it said, if you have one device connected today, you'll have 10 to 100 times increase in the connected devices. Means in one house may have minimum 10 or up to 100 devices connected with your network together. Even at home, currently we see 5, if you have 4 people at home, everybody, if you have a Wi-Fi using, everybody is connected to the Wi-Fi. 4 devices connected at a given point of time. So this may increase to 100 folds or 100 times, they will be increasing. That's what the massive machine connectivity. And the latency, it is expected that it will be 5 times lower than what is with the current system. If it provides, if you remember that the end-to-end delay, what you get is almost an TCP connection for an internet less than 100 millisecond a good delay, we average 190 something, or it's sometimes 200 millisecond delay in the TCP data traffic on average in the country. Americans at some places it is almost they call it zero, but it cannot be zero. And African countries, if you go, it is more than 300 milliseconds delay. It's a huge delay. So that's still a problem. So the low latency talks of 5 times lower latency. If 4G provides a 50 millisecond latency, then 5G is expected to have it 10 millisecond delay. That's what it talks about. 10 to 100 times increase in peak data rate. See how much data at a given peak time. Everybody goes morning to the office and you start with your internet and start watching your emails. That is what the peak data rate at that point of time. So the peak time even says there will be increase of 100 times in the peak data rate with the 5G. That is what all expectation comes from manufacturers of devices, equipments, and also it may be expectation from the network mobile operators who are going to provide those services, who are still reluctant to put revenue on this. And not only that, also, when I say manufacturers, the battery also is an important issue, because with the huge connectivity, a huge amount of data traffic, and will also put pressure on the battery life. And that it's a 10 times battery life expansion for low power devices. That is what is expected by the industry. Whether it happens or not, this seems to be a very difficult one, where the battery life 10 times expansion for low power battery around, but that is what is expected from 5G. So it seems a hugely ambitious vision, because delivering 1,000 folds increase in data volume is a very difficult task to achieve. 50 times better than the best interest volume increase, moving from 2G to 3G, is a difficult one, ambitious one. 500 times better than achieved what we achieved with the 4G is also very ambitious. Accomplish above while getting this much higher data rate and peak data rate and volume of data, but at the same time achieving a very low latency is very hard. That's what the vision seems to be very ambitious, but it's not achievable. It is not like that. It can be achieved as the technology is growing, but seems very ambitious. But that happens, probably we don't know what will further happen. Yes, as the reduced latency tends to reduce efficiency, that may not happen, but this is also highly ambitious, that if you reduce latency, that the efficiency, this may also reduce the efficiency. That's a questionable point, because more and more users will try to use it for multiple purposes, then efficiency may also reduce. So what is some of the MNOs or mobile network operators or expert in the those who are dealing with the 5G? They said the 5G vision should be realizable. It's not very realizable. This is not very clearly realizable. That is highly ambitious vision, and therefore they said that moderate it, that it could be a realizing vision. This is what the IMT said. The vision highlights the cloud-based services. It must support augmented reality, high-definition video, high-speed data access, automation in the industry, and mission-critical communication and IoT. These are some of the vision highlights, that access to those kind of services and provide those kind of services basically, and which I'll say this is what I've taken from this Next Generation Mobile Network Alliance 2015 document. This talks about various kind of applications which 5G should provide. They have been divided into 8 groups. These groups are the broadband access. I'll talk one by one. First is the broadband access, where I should have access everywhere, anywhere. So in a dense area, like if you come in Delhi to a huge market area like Lajpat Nagar, where huge population and dense population, the connectivity is a problem. If you go to the basement of a building, you don't get connectivity. So in dense area, so we're trying to differentiate between the access in a dense area and in a very sparse area if you go in a rural India, where the population is not densely there, so you don't need a very high bandwidth. And if you go to a dense area like market area in a metropolitan cities, there are high-rise buildings very close, so the penetration of a signal becomes a problem, and where thousands of people live. So it should be the broadband access. It should be able to provide connectivity to a dense area as well as a very sparse area, with a minimum, intended to provide minimum experience anywhere. So at least you should the minimum threshold of good experience should be achieved where you go to a dense area, you go to a very rural area. That is what the whole idea of broadband access is. So in dense area already provided by the 4G, but how do 5G? Because the more devices will be connected. So if you look at that way, everywhere requires enhanced network coverage. If you are trying to provide coverage everywhere, you need the enhanced network coverage we talked about, where probably in somewhere you need a 28 gigahertz connection, and somewhere you need a 700 megahertz connection. If you go to the rural India, 700 megahertz is sufficient. If you go to dense area like in the Ruptes, you need 28 gigahertz bandwidth. That's what we are talking about. So technology required that provides coverage at low cost. That's obvious. But higher user mobility, that is one of the application what is to be supported by 5G. If you have a high-speed train, 400 km per hour, so the demand for the mobile service on those kind of moving trains will be highly expected, and that demand is growing. And 5G is supposed to provide this service. If you have a high-speed train running in India, we also need that. This because, as I said in the beginning, if you move to an area where there is no coverage, the high-speed train not only requires coverage, but it's a fast signal, which is speeding at a very high rate, should also need to process the signal fast. So that's what, and even inside a tunnel, how do you get a service? Probably 5G will be able to cover that. If you use it, what you call our MIMO services, it will be able to provide that. Then other issue comes that the 4G with LTE mobility and narrowband IoT are sufficient where 5G will add cost. Is 5G adding to massive Internet of Things or not? Some say that 4G may provide with the 4G LTE mobility and narrowband IoT are sufficient. But some say that is not sufficient. It will not be able to handle large numbers. Their 5G will be helpful, but it will add more cost. Whether the users will move from 4G to 5G or not, some people put a big question mark on that. But this is also one of the applications where 5G will be more useful than the 4G. So extreme real-time communication, where what called tactile internet, where humans directly interact by feedback system. You need 1 millisecond or 10 millisecond, not more delay more than 1 millisecond and 10 milliseconds. You have to quickly respond to. That kind of services, that is what extreme real-time communication, where you need very low latency, like your car robotics. If you have a driverless car, the communication has to be very quick. If you have a what you call obstacle ahead, it must quickly respond to. So the communication has to be fast. The latency has to be very low. That's what it is important. This is one of the huge application area, extreme real-time communication, like driverless cars or robotic expedition, where robots are used. Remote control needs a fast response. That's what is another area or application of 5G. Some believe that latency would reduce to 1 milliseconds, and it will be able to handle such issues of like your real-time, extreme real-time communication. But that is what is expected. But whether 5G will be able to give you 1 millisecond latency or not, still one has to watch. So that is why this, though it will be useful for real-time applications, but getting it is a very big challenge. Other application area is lifetime communication when natural disasters come. So application for public safety emergency services will emerge, such as natural disaster. And why they are important? Because they require high level of availability. Right now, the availability of the mobile network is not everywhere. So when we come with the 5G, that it is we providing services everywhere with different kind of themes or the broadband we are providing, enhanced mobile band we are providing, but life will come. They will also support these kind of applications. But also, battery in 4G still have not yet the quality of have not improved. Ultra real-time reliable communication, which is e-health. These applications require reliable machine-type communication, low latency again. Like you have drones, remote surgery, and need reliability. So reliable communication, highly reliable, no disconnection. Also, the security issues will become big challenge for ultra reliable services, where the online surgeries are performed, that robotic surgeries are performed, but they're mission critical or very what you call ultra. These are real time. Some surgeries happening, so you cannot afford with the obstructed network, availability of the network, low latency, whatever you call high data rate, and everything is important for such kind of services. So this is another application area where 5G will be useful. And broadcast like service, your TV should be delivered by services should be delivered by cellular. It happens with the IP telephony, the IPTV, that your Airtel provides you IP internet-based television network. But it needs quality improvement. So with the 5G, probably we get away with all kind of cabling. All cellular network downlinks will be able to provide TV services as well. That is what is expected. So European Commission has already tried with the 4G for these TV services, but it does not so much what you call improvement. No viable business case for this. That means providing television services through cellular network. The trials which have been made by European Commission, the Europe for 4G, has not given much business value. Therefore, it is expected whether 5G will change this or not. And probably the quality may not have been that good with the limited of bandwidth and latency. But with 5G, this may improve. But some says nothing new will come with 5G. But I think with the change in the bandwidth and latency will improve this. Probably people may move to a broadband service through cellular network. That may happen. So, what is the summary of 5G? What I talked about is, as we know, the speed and capacity of 5G, as vision of 5G are not valued by the users. That you have to keep in mind, because some users feel that can be achieved. I'm talking from the Western point of view. We don't have a 4G, we don't use much. So that whatever we are achieving with the 4G as the price value is sufficient for us. So that is what is important, whether if the cost of 5G is more, and if you don't get much higher services, then it will not be valued by the user. That's what it is. But there are some elements of 5G vision that the consistency is more important, that you get a very consistent service without breaking this, and constant connectivity. If 5G is able to provide those, the consistency and the constant connectivity, if it's able to provide, probably that may value the customer more, and they may move from 4G to 5G. That's what, and the consistency is more likely to improve productivity and social value. That's what we are trying to say, and the connection will definitely will have a better responsive system and will provide new business methods. So to deliver a measure of the consistency is hard. You cannot measure that whether certain services are consistently provided or not. It's very difficult. But it can be achieved by through good coverage and capacity. We are assuming that 5G will provide a good coverage, both wider and short and long coverage, and a little higher capacity of data rate. So with that, probably we'll be able to provide or achieve consistent services through 5G. Though it is hard, but it can measure to hard, but we can find consistency in the services provided by the 5G. So the areas where coverage and capacity is problematic are the transport, especially train business, as I said. We assume that 5G will provide a consistent and constant connectivity in moving trains, fast moving trains. That is what the problematic challenge area is. Rural area is also challenging because if you provide all these, you may not get the revenue back. That's the problem, whether mobile operators will be ready to give it or not. Buildings and including home offices where huge large number of people stay there or live there or work there, then you need a huge connectivity is a problematic area. But very dense area like at an Nehru place, and that may be also problematic. But whether 5G coverage and the kind of coverage we talked about with the 5G, probably they will be able to achieve these. That is what is being talked about. So the future of 5G seems to be bright. Vision with realities. It will provide you nationwide IoT service that will be doing a transformational transformation in the society. If you have an IoT service, everything is connected with the internet. It will be an achievement. And yes, consistent connectivity will be a huge change that will bring to the whole business as well as in the society for entertainment value. That will be appreciated by all mobile users as well as internet users. That is what is expected. But it will be 4G will be more than a new generation. If a dream comes true, it will not be a generational change. It probably may be an era change. That is what is expected. Let me see how much time is. Then I'll talk few things and coverage. Few things I'll skip. Let me go in, when we talk of high speed, before I go on the data management, let me say a 4K video with 4000 horizontal resolution requires 20 Mbps. That is what is the speed is that 20 megabits per second is required if you are choosing a 4K video with a 4000 horizontal resolution. That is what the demand is, speed demand. But this speed demand is also limited by the small size screen of the mobile phones. Even if you deliver this kind of video, probably you will not like to watch this kind of high quality video on a limited small screen size. And that also may be a storage is a problem with the mobile. So this is limited by the small screen of the mobile phone. So you will not like to watch this kind of video on the mobile phone. But you may also like to watch this kind of movies on your laptop. So the demand, if you look at, is not very high for a speed. Now, if the 5G talks on a very high speed, whether people will move to that or not with the high cost. The cost with the 5G will be important. So, like the Netflix recommended data rate of 5 Mbps for high definition videos. Netflix, everybody may be watching Netflix. It says that 5 Mbps for high definition video is sufficient. And 25 Mbps for 4K ultra high definition, as I talked about. So it said if you have a 25 megabits per second speed at your net, then you can watch a very 4K ultra high definition. From high definition to ultra high definition will be sufficient. So now the demand is 5 Mbps for a normal Netflix and 25 Mbps for a very high ultra definition videos. Then the question comes, do you need a more speed than that? So speed, therefore the speed may not be a question for web browsing. So even if 5G provides a very high speed, but web browsing does not put a high demand for a high speed. But latency is a significant for this, which we may cause by, say if you look at latency, so if you look at a turnaround time of a server or delay inherent in the TCP protocol, leaving aside what is the speed or latency reduced by the network devices, but the inherent delay by the TCP because it does lot of activities also, or the servers you use, they will also be creating a problem for even if you want to achieve a high latency rate, your routers or whatever virtualization you do in the routing, whatever kind of technology you bring in the routing, slicing you do, but the question is, there are limitations put by the turnaround time of a server as well as the delay inherent in the TCP protocols, TCP/IP protocols. So, which may cause more latency and put a limitation on the 5G latency. So, the speed beyond 1.5 megabits per second does not increase consumer satisfaction. The meaning hereby, if you forget about interactive games in a normal course, it has been observed that 1.5 Mbps video it does not increase user satisfaction, right? Because any kind of video what you streaming, we do not have buffering also. And the user has a speed at which one watches and one responding. So that is what is said. So if you look at this speed demand load, what it says is a 10 Mbps data rate, it takes only how much even less than 1.5 seconds. That is what a page of size this will take less than 1.5 milliseconds. That is what 6 Mbps. If you take, it takes even a little more than that, but it is decreasing as well. Keep that in mind. But the satisfaction increases as latency falls below the level of 75 milliseconds for video. That is important. So what I'm saying, 1.5 megabits per second may be sufficient. But what about the latency of playing the video? It says that if it falls below the 75, it gives a good satisfaction. So therefore, the 25 to 30 milliseconds for some other video, if you have a very high definition video, ultra high definition video, probably 25 to 30 milliseconds latency may be sufficient to give a good satisfaction for watching a video. And 4G provides a 30 milliseconds uncongested network. Keep that. If the network is not congested, 4G provides a latency of 30 milliseconds. And if it is congested, it goes to 50 milliseconds. In a highly congested, it goes to 50 to 70. But if latency falls below 75 milliseconds, gives a good satisfaction. And even if 4G in a congested network provides a latency of 50G, probably may provide a good satisfaction to a user. It does not increase very high level of satisfaction because all video is buffered and then played. That's important point. But interactive games and virtual reality, it really may be a problem, even 20 to 30 milliseconds latency. So therefore, the MNO, the mobile network operators, they try to focus on a reduction in the congestion in the network. That is what their primary goal is. If they provided an uncongested network, then the 4G will provide a 30 millisecond latency. That means 4G provides speed in excess of 100 milliseconds, then the 3G, 10 Mbps. Some MNOs, mobile network operators in the 4G market, say that the 4G provides a speed above 100 Mbps. That's what you. And if it's a 1.5 Mbps is sufficient for a user satisfaction, and 100 Mbps may be huge. So now the question is, the speed is faster than 4G really required or not? That is what the questions are being put to the 5G. Some says perhaps not. But if you look at and that interactive games and virtual realities are so important or not. Yes, if they pick up in the market, then it may be important, the speed and may be important, but beyond 4G is important or not, but the latency will match. But the ensure speed does not slow when the demand increases next. Now the question is, even if 4G may be sufficient for the what kind of applications we run today, but they should not slow down the demand for increase next. But we may have new applications coming in future. They may demand for the high speed data, but if you have already a network with the high speed, probably we will be able to meet the future demands as well. There's a huge I can talk about, but I'll not go. I'll straight away go my what you call last few slides. Let's skip a few slides. But if you look at this data management in 5G, as I said, it is going to generate a huge data with the massive machine or a machine connectivity. Then the focus of the network operators, those who provide network services, are on the following building blocks of data management. They say control and service integrity. If they provide this, then 5G will take up easily, and using data to deliver insights. Then quality of the data, the investment on how much they have to invest on their data management, the total cost of the ownership, and then it may also put some innovation it must lead to. If you go one by one, what is the control and service integrity? So now, as far as data management, the continuous flux of change in the data while maintaining service integrity is a challenge. Now, that means when you move from 4G to 5G, and then there is a continuous change in the flux, the data freight, and can you maintain the service integrity with that? That means what I'm trying to say is that with the 5G, the security and the change, whether the 5G will be able to meet the changing in the data requirement and application requirement, different kind of application will produce data, whether 5G will be able to maintain the legacy with the previous tools and supporting systems or not. That's what is important. The speed of service that necessitates fast response. That means if I'm moving on the train and fast high-speed trains, that may need that it must give a faster response. Certain services running, the data management may need a faster response too, even if, and it may also require some kind of intelligence. That means rather than all the time going by, say for example, if it produces huge data, and if I search linearly, probably some intelligent searching applications may be required. Then availability, now auditing of that data when something happens, how do you identify the anomalies? That's important. If everything is happening with the fast rate, like playing an interactive game, if something happens, how anomalies happens, how do you identify that quickly? And that is where you need a fast response, and certain kind of level of intelligence should be built in data management, so that whatever moves you are doing on the interactive games or virtual reality, all data, whatever it is to be accessed, has to be immediately identify the anomalies and access the data and provide what kind of service and integrity it has to provide. Then it should have it should be able to filter out the key data. While the processing is continuously going on, because huge amount of data coming continuously, it should be able to filter out the important data quickly and faster, because this is the bottom line for the impact of 5G, the critical bottom line for delivery of the services in the 5G, the filtering out data in a continuous processing flow. When continuously data is coming with the high rate, low latency, then how quickly you can filter out the key data. That availability has to be there in that data management, and therefore data analytics becomes important there. This filtering of key data sets to support a specific analysis or action. So you need specific analysis and action where machine learning techniques, other things can be useful in data management to filter out the key important issues. The moment the event happens, quickly you have to filter out, because the speed is very high and response required is very high, because it is providing a very interactive services. Stream processing will play a critical part in data refinement. When a stream stream of data is coming, how do you process the data refinement? That if it has to be processed quickly, the refinement where you have to remove the noise and other parts is very, very important, and missing values of the data. How do you take care of that in 5G with the faster speed and high interactive application? This will be very, very important in data management. Of course, the quality of the data is very important. The measuring and validating quality of experience. Now, quality of experience of a user is very, very important. So it is possible. This is one of the important imperative of 5G service, that it must provide quality of experience. That's what whole idea of reducing the latency and providing high services. It should improve the quality of experience. How do you validate that? How do you measure that? We need techniques, data management techniques, where the validation of that data is done. So therefore, the data management will play an important role in validating these services. How do you do that? Right? That's important. And then the investment is another issue. The operator must also they see whether the data, the deployment of the infrastructure for the data management or whatever data is coming there, will it provide us the return back or not? Is another important issue for 5G and data management in 5G. They look for a prolonged investment, that it must keep what you call be in line with the legacy systems for the business processes. Whatever business process has been running with the 3G and 4G should be able to run with the 5G. If it needs extra services, extra techniques, extra tools, extra infrastructure for data management in 5G, whether the cost incurred in that, whether they will get the return back or not. If I go on software solutions or the core network, I need a lot of data management services there. But if I spend as a mobile operator on that, whether it will return me back the money or not is a big question. That is where the investment is another issue on data management. Then it comes to the total cost of ownership. So many existing data processing platforms are very clumsy or very clunky or very heavy and witty and wildly. So they require multiple applications to deliver an end-to-end mediation and enrichment flow. That means what I'm saying is the data processing, the different processing platforms are, whether they can, data coming from these applications or multiple platforms, whether we are able to handle in the 5G or not, because 5G is able to provide different kind of services. We need a lightweight solutions which can run faster for a fast response in 5G. And last is innovation, where the fragmented data from multiple sources coming. As I said, fragmented data, what we are trying to do is the 5G will be a sliced network. Like we have a virtual networks, you have, yes. So similarly in 5G, what you say is the network will be divided into, virtually divided into parts, and every part will be providing different kind of services. When different kind of the services are provided by different kind of network, as I said, I talk of different groups of applications. If I divide my 5G network into slices, different virtual networks, some network is providing ultra reliable communication, some are providing extreme real-time communication, some are providing broadband services. So these are called fragmented data coming from different sources. May be very difficult or extremely difficult to organize them. How to organize data coming from multiple sources together and handle that. Then what I'm saying, when multiple fragments of data are coming from heterogeneous source, then it may need some innovation to handle, to deal with that data. And ability to selectively filter key pieces of information and to correlate with the other data set, then uncover hidden data to have an intelligent service on selecting the key pieces of information from that data will be important in 5G. And that's what. So aggregation of this data coming from multiple sources, how to correlate them, will be a real innovation for 5G, and where ML and AI tools can be useful. So in summary, what I'm trying to say is, in conclusion, the huge amount of data produced from massive machine connectivity will require huge storage. You can say storage may not be a problem, but storage, even if you have used the management of storage is a problem. You need fast searching, sorting for this huge amount of data coming, and better data structures for organization of data in the 5G because of the huge amount of data. So in the conclusion, what I'll say is that the 5G will deliver massive data. So data management is going to be a big challenge that way for the 5G network. But however, in spite of that, 5G offers tremendous opportunities of different kind of applications, as we talked about. Will have a value addition to the society. But the achievement of reduced latency and high data speed may be restrained by the existing data management techniques. What I'm trying to say is, even if you don't believe the existing data management techniques and tools which you use, if you have huge amount of data generated by the 5G, the response in searching and sorting may also hamper this reduction in latency and the speed, whatever we achieve. But if your data searching algorithms are not very fast, the data, if you have to put a response, if it is not searching fast and the huge data, then probably my end-to-end delay will increase, even if the network provides low latency. So that's what I'll conclude here. With that, I'll thank any question. Thank you very much.
Thank you, sir. Thank you for your nice discussion on this data network and computer network and data management in the 5G area. We learned a lot from your session, sir. This is a nice and quite usable session for us, sir. You are in depth in 5G data network as well as the usability of handling societal problem like natural disaster and e-health. It is a very fruitful and very useful discussion and informative session for us, sir. And innovation and research area you have discussed is quite fruitful and usable for all the faculty members in this area, sir. Thank you for sir your nice session. And
thank you.
Professor Tripathi sir, our directors are also want to say something, sir.
अरे सर तो जो भी कहे वो तो आशीर्वाद है.
Yes sir, yes.
मैं कुछ कहूँ इसके पहले. अनीता यादव जी जिन ज्वाइन हुआ है. अनीता.
अच्छा है अनीता.
अनीता यादव.
जी, Anita ma'am and R.S. Yadav sir also joined this session.
Okay, thank you.